it?
All you have to do is keep it here. Just speak into this. That's all.
Okay, but hold on.
Yeah. Mute yourself.
Yeah, I'm.
And mute. Yeah, so mute your speaker. And you're here. This is all yours. Share your screen.
Yeah, I hope you can see my screen. Can you?
Yeah. Yes.
Okay. Thanks. So actually, my topic today is SWE agent, and what interested me into that is the title here. It says SWE agent takes a GitHub issue and tries to automatically fix it using GPT-4 or your LM of choice. It solved 12.29% of bugs in evaluation and sets 1.5 minutes to run. So I thought, like, let me check it. And then there are some information about SWE agent on GitHub. This is right off the press. It is paper is still yet to come on.
Increase the font a little bit. Maximize your screen. Increase the font.
Now?
Yeah, excellent.
Okay, so what I was saying is this Princeton NLP SW agent project. This commit is very fresh. Everybody is working. Last one is 1 hour ago, and as you can see, actually this is very fairly new repository. So I thought, like, let's see whether it solves one of the issue in real time, in the real world scenario. Okay, so they have done some comparison with Devin, and one of the YouTube video, what I see is the comparison says that Devin takes 5 minutes to solve a problem with a 13% accuracy, 13.84 accuracy, while this SWE agent runs in 90 seconds and comes up with 12.29% resolved accuracy. Though this accuracy is very low, and my ambition was very high, so I tried with our Cloudera open source project. We have Hue, our Cloudera open source project. It is fairly big. I can show you the current project size is about 700 meg of size, and it has multiple it has Python files, Java files, HTML, React, and all components. This repository is over 8 years of work. So I said, okay, let's see whether this SWE agent works on a real world scenario. So in their README file, they have a setup instruction that you can run with a Docker. So I followed this, and by the way, they have agent computer interface ACI, and it is nothing but an instruction framework or instruction, and I'll go through that. But what I did is I tried installing this Conda and development version, and then activated SWE agent and ran. And here is my status. And let me just take you to the instruction what they have provided. So we can go to their config, and in this config, this is a generic config where you can say default form URL, which is a GitHub URL. If you want to get down, if you want to solve any issue from URL from GitHub, you need to use this config. So this config says, let's say, if you are a programmer, you are a autonomous programmer, and you give doc response format, and so as it goes further. So I downloaded my OpenAPI key and GitHub key, and one of the documents says that you need to put those keys into SWE agent here. I can show you that in the, yeah, so here add your API keys and tokens. So I put down my API keys and tokens, and then I ran that setup on my live repository, on my GitHub repository. So this was a question. So let me take you to the real world scenario where in the GitHub, in the Hue Cloudera GitHub, we have one of the simple problem where issue is like, am I on like? So the issue is implement. Okay. So yeah, no, this is issues. Sorry, issues. I was in the pull request. Sorry, and the issue was this: how can I remove a health tips? Okay, health tips. So there is some there is this question issue, and they want to solve. And our engineers have a back and forth communication, and then we identified this is an improvement or this could be a bug. So I ran that issue as in the, okay, you cannot see this, right? So so I use this as an engineer. I wanted to solve this issue, and I ran this issue. Okay, I'm sorry, this is now too big on my screen. So here is my setup. So I activated conda activate SW agent, and then I ran this setup script as per the document. And then here it started, and then here I gave my, there is this open source pvlib Python issue. I said I don't want that generic one. So I wanted my GitHub Hue issue to be solved. And somewhere there is a Hue issue which I asked him. So it interacts with that Hue issue. Yeah, here. So here is this Hue issue which interacts. Sorry, my, and it yeah. So anyway, so it goes through all my Hue code and try to suggest me this, and this is very clever that, okay, it is doing this step-by-step inspection and say, okay, there is this context pop over, and not only one, there it started with 10 different thing, and it started looking, inspecting that issue and said, no, this is not right one. It started inspecting other files, and this is out of the blue. It has no knowledge of these files, no knowledge, and this is a real world scenario. And finally, it was going to this KO issue, which is right, which is which is to the point it is going. But in between, I reached to the maximum cost of Open API. The cost limit exceeded. Otherwise, it was reaching to the real world solution. So this is very scary.
So you're going to use it and go on vacation.
And it also played those runbook.
I didn't see that. So his job is still there.
And it also played those runbook into the command, and
wow,
yeah, it has the runbook too.
Wow.
So this.
The moment he has shown that, and he's like, oh my job, I'm sick.
Yeah. Okay. Thanks.
yeah, this is amazing, guys. This is yeah, amazing. Rising up to the full potential that we expected, Prakash. So, guys, do you realize that he, in one day, he learned about SW agent, used it on a real project, on a real open source code base, and solved a real bug.
Yeah.
Right? This is the shortest journey from learning something to an actual utility. And I think today, you will have one less bug. That's really amazing, guys. I would say that this is really amazing. And one thing I would like to point out, as he should, do you notice that there's self-feedback? Another theme, another design pattern for agentic thinking was self-feedback or self-critique. It came up with 10 suggestions. Then it critiqued itself and ruled many of them out and said, okay, this is the way to go. And when it did that, it actually went and solved the problem. So this, guys, is not something, for example, you would have expected from LLMs. It was not the way to think. Just a few months ago, before agentic thinking sort of took over, we are beginning to realize that we are on the cusp of something really big. So there was an idea that, AGI, should it ever come, will be this ginormously powerful one model. But now it looks more like lots of agents, right? Being orchestrated and collaborating, and lots of tools working. So imagine a tsunami of agents coming at you, right? So a wall of agents. That's why in the course portal, I put all of these little agents there, or robots there in front of you. So anyway, excellent presentation. Questions?
Yeah.
Go ahead.
So in this example, is it only the self-critic or there are agents involved? That was not clear from the
See, the definition of agent is a bit fluid. What you don't see is a lot of agent orchestration, but you see an agent breaking the task down into steps, planning it, self-critiquing itself. So if you look at the four main criteria, it's doing a lot of that. What you don't see in this particular case at this moment is a lot of multi-agent orchestration, but some tooling is there. It went to GitHub, it pulled the code.
Yeah, and
it
there is
did all
itself, sorry to, but there is if you go to that SWE agent,
Yeah.
in the config, that conversation steps as an instruction framework,
Okay.
it is written.
It's there.
And it actually did the git checkout, inspecting files closely. It is mind blowing that.
Yes.
Like
Right.
687 meg
Yeah, Albert, go ahead.
So,
gig of data.
so Prakash, 12%, 13% was the average for both the stores, right? Devon and the
Yes.
So normal engineer, would they even get up to 12%? Because many of them can't solve all the bugs. Right? They can solve maybe 5% of the bugs.
I'll be happy if they solve $5 a week.
Yeah. So
And also there is a difference between back-end and front-end engineers and all, right?
Yeah.
So imagine this is a front-end issue and it might then fix it, right? So.
That's right.
Can I say also it's a quality of the issue described in that?
No, that, in fact, that quality of issue is so worst, so pathetic that this guy was not even describing quality of issue. So still it tried to take me to the right direction. That itself is a mind blowing.
Yeah, so Prakash pointed out that the bug, as it was mentioned in the ticket, was actually pathetically described. And nonetheless, the agent was able to make head and tail out of it and make head and tail out of it. It's still point in the right direction and solve the problem, more or less solve the problem. This is quite amazing, guys. So anyway, to summarize, you saw breaking the planning, you saw breaking it up into small tasks, you saw self-critique, you saw the use of tools, and you saw orchestration is not all that much, but it's still, some level of coordination is happening here. And it's like, this is the beginning of things to come, of course. And as Prakash was saying, he's saying it's mind-blowing.
So, would it be advantageous to train models with a larger output, like token output? Because I think right now, it's the Google models are the ones that have up to 8,000 token outputs.
Yeah.
Most of them are either in the 2,000 to 4,000. But input context is the one that's large. But
that is largely right. So output tokens are, I think it's a little bit harder because, see, there's this, Patrick's question is, what is the advantage of having a very long token length? See, I can tell you to the risk of very long output token is what Land you can call the diffusion of errors. If the probability of making a mistake is only 1 in 1,000, right? Yeah, token mistake, a very low 0.1 probability. By the time you reach 1,000 tokens, you're already beginning to drift apart. So it's hard to keep it on track. For someone to say that I can reach 5,000 or 8,000 tokens and still get it is a little hard. And so my own feeling is that, yes, you can do a lot of research and still try to keep it on track and battle the problem of diffusion of errors. A better way is to just break it up into smaller parts and get smaller outputs, like you were doing for your for medical data format. You were getting small pieces and then weaving the small pieces together. And that is more of a breaking the task down, planning, and so on and so forth.
I said we're adding White Star already. So White Star can probably keep this one.
Yes.
Keep generating
that. No, the trouble with White Star is at this moment. So if you played with White Star, it does very well with reasoning tasks, but ask it something very simple. Right? And then it sort of goes astray. So it is not quite a perfect tool. You see, if actually, if you notice that in the Jupyter notebook I gave you, it was the best of times, it was the worst of times, and it completely got lost. Something that a normal LLM would have just nailed it down, right? So what happens is you achieved a very good reasoning ability and like, but at the cost of losing something. And I'm sure they'll fix it, but at this moment, that's an issue.
So I think code generation is much simpler problem than other buckets, right? Yeah.
No, and also another thing I failed to show you, which I was showing, we have a configuration file. So it inspected configuration. It inspected environments. It inspected the, okay, I'm not finding this. Okay, I'm progressing, I'm not finding this. Then it looked into the actual code file like get grep command. So this is like